Another example of a while statement. I'll let you try it on your own. You can just copy and paste it into your source window and explore how it works. But as you can see here, what we have is two variables declared above a while loop. So x is 10 and total is 0. We have a while statement, which is a while loop. So we have a condition. So as long as x is a positive number, which it is, we begin to execute this over and over and over and over again, right? So total accumulates x. Then we decrement x by 1. We keep checking condition. It's still above 0, so we keep going, keep accumulating, and eventually we print the total, because at some point x will become a 0 because it will be steadily decrementing, and at some point will become a 0 and condition will be no longer true, and we will drop out of this loop, and this will be the next thing to happen after the loop. So we will print what the total is. You may have heard about endless loops. The endless loop is obviously, if it's truly an endless loop, then it is probably something incorrect in terms of the program logic. But in general, anything that is just based on user input or some other condition that somehow is derived from user action, essentially something that could execute really long time and many times loop over here, considered to be an idea of an endless loop. Like for instance, we set a string response to yes, and as long as we check and it's still a yes, we just keep doing it. And then we ask the user, you want to continue, and see how we have the scanner somewhere available to us. So we get the response from the user and we begin to compare. So the user could potentially answer yes, yes, yes forever and never end this program and run it for days and days and days like this. Perhaps they calculate something daily using this program. So it could really be interpreted as an endless loop. But at some point it may be able to terminate. And that's a good thing. Another example of the loop here is just something very similar to what we did on the prior slide, but this time instead of using x, we're using an index. And by the way, when we have some kind of variable which participates in this condition and clearly is in control of this condition, in other words, this loop completely relies on the value of this variable. This variable should be recognized as a loop controlling variable. We will give it much more attention when we start talking about the for loop statements, which will be happening in our next videos. All right, so that's just another example that accumulates indices, and you could also add a print statement at the end of it. A few new operators. We actually experimented with the logical not over here, but there are also other logical operators such as and or, which allow you to group conditions together. So basically, if this is a small expression that checks just one variable and one constant value, but we want to be able to combine it with something else. For example, if I want this counter to be controlling this loop, but instead of just having from 0 to whatever number, to 0 to 5 or 0 to 4, whatever you're doing in this condition. And let me get rid of the value here. So one more time, just run it. You see it prints 0, 1, 2, 3, 4. So this loop is designed to process numbers 0 through 4. Okay, it's obvious. It's just pretty pretty standard type of situation. But what I want to do is maybe I want to keep this in range, say from 5 to 10. Okay, so essentially I want to combine this count. So let me change it. I want this counter to be greater than 5 and less than 10. Something like this, right? So I really want a range. And maybe I want to include 5 but exclude 10. So I really want to print numbers, say starting with 5. Okay, 5 or greater than 5, and then stop the loop when it gets less than 10. So ranges like these are not a good Java syntax. It will not compile, because what happens is that the compiler sees these two relational operators, greater or equal, and then greater than, or actually less than, equal, and less than, right? And so it will first evaluate, apparently, my expectation is that because both have the same precedence, it would try to evaluate the left-hand side. So it will evaluate this, right? It will do this, just like if the parentheses were specified. When this is all evaluated and all decided, say this becomes a true, right? So when it's evaluated, this condition turns to be a true thing. And look now at the syntax. We're trying to compare true, like now let me get rid of these, like, parentheses, we really don't need them. So eventually we may end up trying to do something like this. And Java does not allow to compare Boolean values with integers or mix them with any other data types. It doesn't allow this. If I try to compile it, window, projects, my project, clean and build, take a look, error, bad operand types for binary operator less than. This basically says you cannot do this against this using this operator. Something is wrong, just fix your logic. So how do we approach it? So let's go back. I will just rewind back to the way it was written, like this, which is not too bad. But basically what we need to do, we need to separate these two comparisons with 5 and with 10 and make them two sub-expressions, and basically say as long as this and this is logical and, as long as this is true and this is true, this loop should continue. So let's try to see how this works and if this really works as expected. So this is what is happening. I'll resize it for you. So it does print 5, 6, 7, 8, 9, right? So it goes through the loop, and basically we start with some kind of counter value. It checks this condition and it happens to be true. Okay, so it then says, oh, by the way, there is another part that I need to check, and it then compares this value with 10, and this is still true. So both this is true and this is true, and the outcome of logical AND when both sides are true. So it starts looping, right? And then eventually one of the conditions becomes false, whichever one happens to be. Apparently it's this one which will be a false, because all of our values will be greater than 5 when we keep looping, but at some point it will become 10, which will make this condition fail, and the loop stops. Okay, and logical OR just basically says if this or this is true, when both are true or one of them is true, then it's okay. So these are the Boolean operators. So they're very popular because a lot of times you do have to combine one condition with another, and then these are your choices. You can invert logical true or false, and you can also combine sub-expressions into larger logical expressions. So you just really need to experiment with some of this to get a feel how it all works, and you just need to see how how your expectations match what the result you're getting when running your own code. So I think that at this stage, as we begin to enter discussion about loops and other logical constructs, so there's more decision making, there's more opportunities to make a logical error. You really need to begin to experiment more and more and more with your own coding, because what I show you here is just my thinking about it, and I give you a limited amount of examples, but you need to start working when you read the book and you see a coding example in the book. Don't hesitate to copy and paste this into a little program like this and try to make some changes and see if it works as you expected. So this is trying to present a very similar example as the one that we already had discussed right here. So I'll just skip over these, and there's this discussion that we already had, and so that concludes our presentation.